Okay, good morning, everyone. My name is Gracious Yaro, and today I'll be taking you on server-side template injections, which are SSTI vulnerabilities. Now, today what we'll be going talking about SSTIs. What are SSTIs? The impact of SSTIs. How do they arise? And constructing an SSTI attack. Now, under this, we're going to talk about detecting the vulnerability, identifying the template engine, and then finally exploiting the SSTI vulnerability. Then, lastly, we'll talk about how to prevent SSTI vulnerabilities. Okay, so now, what is SSTI? Now, an attacker is able to actually use a native template to inject malicious payloads into a template, which is then executed server side. Please pay attention to the server side, like in the name SSTI. Now, SSTIs occur when user input is concatenated directly to these templates rather than passed in as data. Now, usually when the templates load data or render the data or the user information instead of um just receiving passing the data that was passed in, it actually renders it, like it's concatenates it to the template and then renders it instead of just displaying it. Now, I said template engine. So what are template engines to begin with? Now, template engines actually generate web pages by combining fixed templates with volatile data. Now, template is actually used to display informations about users or products, like all these on organizational websites. It's way easier to just use a template to display all this information. Now, some popular template engines are Smarty Tweak, which is a PHP template engine. We have Java. We have Velocity. We have FreeMaker. In Python, we have Ginger, Marco Tornado. JavaScript, we have Jade, and Ruby, we have Liquid. Now, the impact of SSTI. Now, SSTI exposes websites to a variety of attacks, and this depends on the template engine and how the particular application, that particular web application, uses this template engine. Now, this can actually be catastrophic depending on this particular use. Now, this if the attacker gains remote code execution and has it's severe when the attacker gains remote code execution and has full control over the backend server. Now, this is actually on the severe end. Now, that attacker can then use that compromised system to attack internal infrastructure or obtain more information. So that's on the severe end. And that scenario can be when if the RCE isn't possible, an attacker can gain access to severe information, that severe data, and also arbitrary files. So this is actually on the high end as well, even though it's still not on the severe end, but this can also be catastrophic too. So moving on, now how do SSTIs arise? Now, like I said before, they actually arise when the user input is actually concatenated into the template rather than being passed in as data. Now, static templates that just actually provide placeholders for imputing dynamic content and rendering them, they are not actually vulnerable to SSTI. However, templates are actually just strings, and some developers just concatenate this user input to these templates, now concatenating the string to strings and then rendering it together. Now, this is where this issue arises. Now, this is an example of a non-vulnerable and a vulnerable code. On my left, on our left, we can see here the username, that's the user first name, is actually not really passed into the template as data. It's barely passed in. Now, this is actually using parameters, so it's retrieving that particular parameter and then displaying it. But if you look at our right, the code on our right, here it's actually the data is actually generated dynamically. Now, actually, this is what makes it vulnerable because the user is now able to pass in malicious data and then render it, because now the user is able to generate this data that is passed in and then it is not static. So now, constructing an SSTI. Now, this is the methodology or the high level process. Now, first of all, we move on like to detecting the vulnerabilities. identifying the template engine and then exploiting it. Now in exploiting we have to read the documentation. That's why exploiting we can read the documentation, we can explore, let's look at maybe environmental variables and then attack it. So now these three steps are part of the exploitation phase. Now moving on to the detection. Now SSTIs, do they actually go unnoticed because they are complex? No, they don't. It's actually because when an SSTI can only be found by a security researcher that is looking for it, like by someone that is actively searching for that vulnerability, that's when it can be found. And it's not something like you can just like um notice while going through the site. You have to actually look for it. Now, the simplest approach to actually forcing or testing for an SSTI vulnerability or detecting it is actually using a polyglot payload. Now, by polyglot payload, it's actually just a generic payload to test for the SSTI vulnerability. Like I said, different template engines you have use different template languages, even though they're actually very similar. Most of them are actually similar. So this polyglot payload can help us test for it. Now, after we've used this payload, if an exception is raised, that will indicate to us that the syntax is being interpreted by the server in some way. Now, what if our payload did not work? Does that mean we should stop testing? No, it actually doesn't. Even no matter the outcome of our payload, whether it works or not, we still have to identify the context of the vulnerability. Now, what do I mean by context? We'll come there. Now, when we're talking of context, we're talking of either the plain text context or the code context. Now, what is the plain text context when it comes to detection? Now, most template languages actually allow the use of HTML tags, or you can just use the template native syntax. So now, native syntax like we saw before, render, hello, username, but when we're talking of HTML tags now, I'm sure that should ring a bell. And we're talking about XSS vulnerabilities now, cross-site scripting vulnerabilities. The thing is, SSTI vulnerabilities can actually sometimes be mistaken for SSTI vulnerability. SSTI vulnerabilities can sometimes, most times, are actually mistaken for XSS vulnerabilities, and then this once an attacker should see this, they actually just ignore it because they think it's just an XSS vulnerability, and then go further to testing for the SSS, but discover that it doesn't like work or there's something wrong with it. Well, the thing is, most times they're actually usually mistaken. So it's really advised to check for SSI vulnerabilities as well whenever you notice something similar to an XSS. Now, when talking of the plain text context here, we're going to like impute mathematical operations in order to test for this. Now, if we look at this particular example here, we can see the 7 asterisk 7, which can be interpreted by different template engines differently. Now, if we move on, moving on, we'll understand this better. Now, if we move on to the code context now of detection, here, the we'll actually check for a parameter that actually doesn't contain this XSS vulnerability. Now, in the previous one, now, the we saw that XSS is usually SSTI is usually mistaken for XSS, but now in the code context of detection, we're actually going to look for a particular parameter that is not vulnerable to XSS in order to check or test for this vulnerability. Now, moving on, we'll now if we move on, we'll see that here we can see that imputing a tag, if we impute a tag and it doesn't like show us that it's actually vulnerable to an XSS, then we can move on to actually break the template syntax by using the brackets, as we can see here, the curly braces, as we can see now. After breaking this, we'll now impute a HTML tag, and then if this is rendered to us, we'll know it's vulnerable. And this is actually the code context of detection. So now I'm moving on to identifying the template engine. Now, like I said before, there are actually lots of template languages, but they have really similar syntax. Now, by submitting invalid syntax, this can actually reveal to us the template engine being used. Like if we've worked on SQLI vulnerabilities before, we'll notice that when testing for, like sometimes when testing for these vulnerabilities, we can see the version of the SQL database being used. Now, in this situation, now it's the same thing. Like if we put invalid syntax or invalid expression, it will give us, it will reveal to us the template engine that is being used. Now, for example, if we're working with a Ruby based Yaro engine, that's this is a template engine too. So if we work with this and then we impose this particular foobar this code here, this will actually trigger a response that will actually reveal that it's a Ruby based template engine that is being used. Now we can actually identify the template engine by testing manually with different payloads. And then after testing, like we're testing manually with different payloads, different types of syntax. So we're testing with this, and then we're going to use the process of elimination to to say, okay, this doesn't work, and then this works for us to know if for us to be able to obtain the particular template engine that it's being used based on the template syntax or the output it provides to us. Now, for example, if when working with Twig and we input this particular payload, it actually returns to us 49, but in another template engine known as Ginger, it returns this particular value. So in Twig, it actually multiplies it, while in Ginger, it multiplies the string. So as we can see. So now this is a methodology or a decision tree to actually help us with the detection or the identification of the template engine being used. Now we can, if we can use this guide to help us identify certain well-known template engines. Um, like I said before, sorry, like I said before, um, this particular Twig and Ginger will actually give us different outputs, but they use similar syntax. So moving on now, time for the exploitation, or more like how you are to exploit it. Now I'm just going to walk you through how you can successfully exploit an SSTI vulnerability. First off, there are different processes. There are different processes we have to follow in order to exploit a vulnerability. That's an SSTI vulnerability. Now, the first one would be to read the documentation. Now, usually as an attacker or as a security researcher, you have to actually get used to reading different documentations to understand how that particular service works in order for you to know how to exploit it. Now, in this scenario, reading the documentation, we're going to learn how, want to learn this template syntax, want to also look at the security documentation. That's search for if there is a security section, or if there are some security implications like wrong with some particular functions in that template engine, or if there are actually known exploits for these particular template engines, and then we can further tweak. Now, the next thing is to look at documented exploits as well. So we're going to look at certain template engines will definitely have some documented exploits for certain versions. So it will be best to understand the documented exploits in order to help you to exploit your target. Now the next one will be to explore the environment. I mentioned environmental variables before. So now here we're going to actually explore the environment looking for exposed objects. This can either be built-in objects that like come with the template engine, or they can be developer supplied, meaning created by the developer. So now we're going to look for these objects if they are exposed, and then some of them can actually reveal some sensitive information to us that can be very, very invaluable during our exploitation. Now next is to create a custom attack. Now, using all the information we've gathered from our research, that is from our by reading documentations and understanding the template syntax, security documentations, documented exploits, and also by exploring the environment, we can actually chain all of these together. That's use the information gathered and then see if we can create a custom attack in order to exploit the template engine. Now, we're going to be looking at, okay, from the information we've gathered, we're going to see if we have some certain objects that we can chain together, either for the developer or for the built-in objects, in order to help us exploit the template engine or to exploit the web application. So now, For developer objects, certain times documentations are actually not available for developer objects. So it is best to actually when manually testing for this vulnerability to actually look at how the particular web application or the particular website responds. So looking at the behavior of the web application. So now, other things we can use tools like TPL map. There are other tools available out there. And then using this particular tool with sandbox escape techniques, this will help us to exploit SSTI vulnerabilities because usually templates are actually running in sandbox environment. So we can try to escape the sandbox environment and then exploit these vulnerabilities using tools like TPL map. We can also use cheat sheets. There are a lot of cheat sheets available online that we can use to manually test for SSTI vulnerabilities. So just researching more and then checking more is going to help us to be able to exploit these. Like what makes a very good security professional or security researcher is the ability, your ability to research, ability to Google, and ability to learn stuff. So it's going to really help us more to exploit it. So now preventing SSTI vulnerabilities. Now the first one is to not allow user modification or allow them to like submit new templates. Now, sometimes it's actually very unavoidable in organizational settings. Like they need someone to be able to modify their template or or maybe suggestions to improve their template. So now this is actually unavoidable in some situations, but it's actually best to restrict it as much as you can, restricting who can modify and who can submit new templates in order to restrict this. But and those particular individuals should have certain access control measures in place because once those privileged accounts are compromised, then it can really be catastrophic because one can submit new templates or upload new templates to exploit this. Now, another one is to use logicless templates. Now, here we're talking of separating logic from presentation. So now separating what the template engine is actually doing from what it's presenting to you. So now most template engines usually combine these together. So they are actually um processing and rendering together. So it is best to actually separate it by using logicless template engines. Now we have Mustache for this. This is an example of a logicless template engine. Now another one is to only execute user code in sandbox environments. Now one of the methods I said for exploiting SSTI is actually to use sandbox bypass methods like escape methods. So that's using really secured sandbox environments can actually help to reduce exploiting SSTI vulnerabilities. So this can be bypassed, but it depends on the measures you set in place. So now another one is to deploy your template environment in lockdown. This is actually under this sandbox environments, like I said, making it more secure. So now when you're talking about a lockdown environment, you're actually setting up more security measures in that particular environment because I'm sure most of us know different ways Docker can be actually be exploited. So trying to like prevent the exploitation of this sandbox environment is going to help you to prevent the exploitation of SSTI vulnerabilities. Now, the last method I'll be using for preventing SSTI vulnerabilities is by sanitizing user input. Now, by sanitizing user input, this will help us to prevent SSTI vulnerabilities because your users cannot try to input malicious payloads in order to test for these or to further exploit these vulnerabilities. So it is best to set up sanitization methods or filters in place to prevent this from happening. So um that will be all we'll be talking about today. Um Please, if you have any questions, you can share with me in the chat. So, So please, if you have any questions. Okay, thank you for having me today. I hope you enjoyed the session. Thank you very much.
A broken dreamer is your mind. All the scars let's leave them behind. We light the world up now. Let us fire in your eyes to the darkness into the night. A broken dreamer is your mind. All the scars let's leave them behind. We light the world up now. Let us fire in your eyes to the darkness into the night.
Fuck that shit.
A broken dreamer is your mind. All the scars, let's leave them behind. We light the world up now. Let us fire in your eyes to the darkness into the night. A broken dreamer is your mind. All the scars, let's leave them behind. We light the world up now. Let us fire in your eyes to the darkness into the night.
shit.
Hope